Now let's move on from predicting customer interest to optimizing a campaign with machine learning. We will now try to find out the customers, those can be included in the promotions, using an AutoAI experiment. Machine learning and AI models are used to provide insights into the business to provide better services and products to customers. Creating models can be time consuming. There are multiple ways to build models. There are even multiple tools of automation and to carry out experiments for statistical analysis, such as H2O.ai. You could use RStudio, Python, or any other programming language individually to leverage model computation on your data in a system, and even you can do it through a notebook. First step, once you plan to import the data to your environment, you have to decide which attributes to use. Deal with absent values and convert all the attributes to a format that is acceptable to you for the chosen algorithm. Then you'll have to try different algorithms to find out which one of them performs the best. There's a better way. Watson Studio includes a tool that can make things and this task faster and easier. It's called AutoAI. With the Watson machine learning service as a part of our project, we add an AutoAI experiment to it and give it a name. A description, we have a Watson machine learning service instance. Our compute configuration is here. We select this compute plan and click create. In the next step, we select the dataset to use. AutoAI then takes a look at the input data and asks us to select the prediction column, which is customer ID in our case. Once that's done, click Run AutoAI Experiment. AutoAI goes through multiple steps. It splits the data, pre-processes it, and then moves to model selection. In our case, we are dealing with a classification model. It chooses from a list of 30 potential candidates. In our case, we are dealing with known behaviors. This is the data of old customers. We are choosing from a list of old customers. You may recognize a few of these algorithms when it comes to selecting algorithm. For example, we see the decision tree, random forest, XGBoost, gradient boost, etc. Gradient boosting is a machine learning technique for regression and classification problems. This produces a prediction model in the form of an ensemble of weak prediction models, typically decision trees. Now in statistics and machine learning, ensemble methods use multiple learning algorithms to obtain better predictive performance that then it could be obtained from any of the constituent learning about them alone. Multiple pipelines are built in this experiment. Let's say for inference, pipeline third is for accuracy. First, data is getting trained from known behaviors. We are building a relationship map for prediction. Customer ID, as we mentioned, before the first step of training for data for known behaviors. The second step is choosing or selecting an algorithm among top algorithms, then working on pipeline for accuracy and different feature selections. Then normalizing data or doing feature transformation on data. Feature engineering includes classifiers, transformation of data, pipelines, and several other features. The experiment starts with downloading source data and selecting algorithms for pipeline generation. Using 10% of training data, discarding underperforming algorithms and keeping the top algorithms. We'll complete feature engineering for pipeline, optimize the model, start the model, transform data for pipeline, complete hyperparameter optimization, complete model optimization, complete feature engineering. Now, which one is the best for our situation? If we're dealing with regression model, AutoAI would select from a list of 44 algorithms. These may include ARD, stands for automatic relevance determination. It is prediction by expectation. ElasticNet and Lasso. Lasso is a regression analysis method that performs both variable selection and regularization in order to enhance the prediction accuracy and interoperability of the statistical model that it produces. RMSE in this case is root mean square error. It represents the sample standard deviation of the differences between predicted values and observed values, also called residuals.